welcome and good afternoon. Thank you all for joining our second webinar in the Tarana Tuesday series, Partnering to Deliver the Communication Solutions Smart AG Requires. Here to present from Tarana Wireless is Account Executive Tim Yeager. If anyone has any questions throughout the presentation, feel free to add them into the chat as they'll be addressed at the end of the webinar. Tim, you're up.
All right, thank you so much. And good afternoon, everyone, and thank you for taking the time today to sit down and listen to how we're engaging with the agricultural market to promote smart ag out there. What we're going to cover today is some of the requirements for agricultural networks and who is Tarana, what makes us different from traditional fixed wireless radios, why now is the time to address smart agriculture, what is driving smart ag, some examples of deployments, how to engage Winncom and Tarana Wireless, and then all your questions. Again, I want to reiterate, if you have questions throughout the presentation, please put them in either the questions or the chat, and we will address them going forward. And if you want to talk about a project, please engage your Winncom sales team, and they will get us, myself and my engineer, on board, and we will be more than happy to discuss your project. So some of the requirements for the agricultural networks, reliability and durability are two of the ones that we see come up in all of the deployments that we're putting out there. Again, you are building these networks and you don't necessarily have the time to constantly go out and maintain, upgrade. So they have to be reliable and they have to be durable. And a lot of this information that you are passing over these networks is mission critical and will cost you money or your customers money if there's any outages of communications on there. Ability to work in harsh conditions. Everybody's radios work great in labs, but once you start to get out into the real world, you don't have perfect conditions. You know, there's going to be wind, there's rain, there's mud. Working in hot temperatures, cold temperatures, you have to have a network that is resilient and can work in all conditions. Ease of deployment. Again, you have limited resources to deploy these networks, and you want them to be as much of deployment and forget as possible with reliability staying up during the length of deployments. Ability to manage remotely. Very rarely do you have people where these networks are being deployed that are in charge of maintaining them. So you have to be able to maintain multiple networks or multiple portions of the network remotely. A lot of people believe that a farm is just a single plot of land. Most of the big farms now are multiple plots of land, sometimes even ranging in multiple counties out there. Increased demand for data, whether it is an agricultural data doing pivot irrigation and smart ag or autonomous vehicle control, the demand for data is increasing and it's only going to increase. The trends are out there. You need an upload speed. By managing these networks remotely, a lot of them have video or sensors put into them. So you need to be able to make real-time decisions. So upload speed and latency are incredibly important to these networks. And then data security. Nobody wants to be the latest network that got hacked or have anybody expose customer data out there. So who Tarana is. We were founded in 2009. We're headquartered out of Milpitas, California, which is the Bay Area. When I started a little over 2 years ago, we had 200 employees. We're up to, on average, of 500 employees now and still growing. We were designed, and go-to-market strategy is to address the $50 billion wireless broadband access market out there. We do qualify for grant funding. Currently, we're passing well over 50 million locations in networks that we have that are production networks. And those locations can be everything from a center pivot to a house to any location that would benefit from using high-speed networks. We're adding a little over 2,000 remote nodes to the various production networks on a weekly basis. And we anticipate by the end of the quarter, that number will be closer to 3,000 remote nodes on a weekly basis. Well over 28 patents pending, with still more being developed out there as we develop the product. Common challenges to fixed wireless access: single carrier channels in a congested spectrum. There's not a whole lot of room out there. And in traditional fixed wireless, you have to alternate carrier channels so you don't cause yourself self-interference. Low spectral efficiency, and that's just what I was talking about, by alternating channels. So the networks will only scale to a limited degree out there. No support for near and non-line of sight for the deployments. And especially in an agricultural environment, foliage is something that you have to deal with. Corn, 6-7 feet tall. You need to make sure that you can handle the signal in that area. Limited interference mitigation, and there was no cancellation. With the deployments out there, you need to make sure that you can hear your communications and that they're reliable. And without interference cancellation, they're just not going to be reliable. When Tarana entered the market, we started to change all of that. We designed to fiber class speeds. When my engineer, Charles, and I work and design out a network, we do it to a minimum of 100 megabits per second on a download speeds, and we do have capability of going up to a gigabit per second per location with low latency. When the FCC has now defined broadband as 100 megabits per second down and 20 megabits per second up. So you need to make sure that when you're designing your network that you can meet this. Charles and I designed to 100 by 100. And the reason for that is we want to give additional lifespan to the networks that we're working out there. High capacity per base node. One of the biggest issues that people have when they go out and deploy a fixed wireless is the traditional fixed wireless has a limited number of remote nodes that each base node can support. And it usually maxed out at anywhere from 40 to 60, depending upon what the throughput is on those. We can go up to 250 remote nodes per base node. And we're seeing an average of about 150 to 180 remote nodes per base node on that. With the largest that we've seen in active deployments is 209. Solid connections despite obstacles. We are a massive MIMO radio, which means we have multiple radios transmitting and multiple radios receiving on both ends of the radio link. And what that allows us to do is to utilize multipathing and reflection to provide additional signal out there for the networks. What that allows it to do is be more stable, greater distance, and greater throughput. We can do this because we have computing power on both ends of the link, and that allows us to rephase the signal and make it usable. Consistent service quality throughout the deployment. We transmit and receive on both ends of the link at the same level. Where if you're using some of the traditional fixed wireless out there, you're much more transmitting at the tower location or distribution location than you are at the remote side. So by transmitting at the same power level on both sides of the link, it's a much more consistent service quality and much more reliable link. And we do have a cloud-based remote management platform that will allow you to manage the network from anywhere that you have any kind of internet access. High quality of service delivery in an unlicensed spectrum to avoid the cost in what is licensed or CBRS spectrum. Simple installation at a remote location. Our remote installs I equate very much to a DirecTV or a Dish Network install for television service at your house. Repurposed technology is not the answer. So Tarana, when we started from the ground up. We have developed up a chipset that is specifically designed for fixed wireless access. The other manufacturers out there are repurposing chipsets from other technologies. 3GPP chipset is a common one that we see, and that is the same chipset that is in your phone and is designed for mobility. The problem with this chipset is on the distribution side, the transmit power is much greater than it is on the remote side. Perfect example of this is when we've sat in venues or large crowded areas where we have 5 bars of service, but yet we can't make a call, can't send a text, can't send an email. And that is because it is so congested that the remote or the base node could not hear the radio talking. It's not transmitting at the same power as the remote. And Wi-Fi is another technology that we see out there a lot, repurposed for fixed wireless access. The biggest issue with Wi-Fi is network overhead and the way it handles data. It's just not as efficient as the chipset that is designed specifically for fixed wireless access. This gives you a little bit of an idea of our product offering, of what we have right now. We have a 3 gigahertz CBRS, and that is considered licensed broadband by the FCC. You have an aggregate throughput at 3 gig at the CBRS at 800 megabits per second, with each 90-degree base node offering 2.4 gigabits per second throughput on the base node. And if you do all 360 degrees, that gives you 9.6 gigabits per second of throughput. And on, again, a 360-degree network, we can support up to 1,000 end users on that. We have multiple channels on our radios, and that allows us to split up the bandwidth required to get the throughput that we're talking about. So you have a much greater chance of finding an unused or non-noisy portion of the network on there. On the 5 gigahertz, which is a completely unlicensed product, again, you got 800 megabits of throughput on the remote side, 2.4 gig on each one of the base nodes, and it acts just like CBRS all the way through, supporting up to 1,000 users on a tower or 360 degrees and multiple channels. The 6 gigahertz is where things start to change for the more throughput and greater functionality. The 6 gigahertz product can operate in the upper 5 gigahertz spectrum, but also the 6 gigahertz spectrum. When you're using all 4 channels, you can get 1.6 gigabits per second throughput on a remote node with 3.2 gigabits per second per base node. Again, that's increasing the amount of bandwidth that you can get out there. And on a tower, that would give you 12.8 gigabits per second of data on there. Again, why we are different than other traditional fixed wireless access. We work in near and non-line of sight conditions. And again, that allows us to work in areas where there's obstacles, foliage, moving traffic on there. We have true interference cancellation on our radios. So we can cancel out up to 40 dB of networks that are out there that are not part of our deployment. And so what that allows us to do is work in high noise environments much better than other manufacturers. High throughput, again, either 9.6 gigabits per second of throughput for a tower or 12.8 gigabits per second in a multi-point environment is incredibly high and allows you to work both in dense environments and in rural environments shooting long distance. Uniform service delivery. Again, that allows we're transmitting the same power on both sides of the network, so you can hear on your upload speeds and transmit on those just as well as you can on the download. Spectrum reuse, what that allows us to do is to scale to much bigger networks than what traditional fixed wireless. Rapidly deploy, again, you can start to deploy these networks and it doesn't take you as long to deploy them as traditional networks. How does Tarana compare to the competition? I chose the CBRS spectrum because if we're dealing with the agricultural nature of these networks, what that does is this penetrates foliage better than the 5 gigahertz or 6 gigahertz spectrum. We did a test, same tower, same antenna height with what our competitors' products up there, and they were getting a usable distance of about 7.8 kilometers from the tower, where we had usable bandwidth 15 kilometers out from the tower. And again, if you look at the closer into where the base is, much higher performance, even into closer into the tower. So we were able to get much better throughput and much more reliable service. That's all fine and good, but you got to have a reason to deploy a network like this. And why now is the time to address smart ag? Smart agricultural is being driven by sustainability of crops. A lot of farmland is being eaten up by development now, but that development is being caused because increase in population as well. So by 2030, food production must increase 60% to keep up with what the global demand is for the food out there. Global agricultural and the IIoT market that supports agriculture is expected to be well over $20 billion. And that was by 2022. Last year, we hit a number of around 23 billion. Unmanned vehicles. We're starting to see unmanned vehicles being rolled out into agriculture in a large environment, in automation in general. Some of the major tractor manufacturers or farm implement manufacturers now have vehicles that are unmanned. And so with that, you also get to be, we're starting to see much more precision being driven into planting, into chemical application, or what they're calling fertigation. And instead of just mass dropping or mass covering a field with chemicals only where it needs. And what that's allowing us to do is to reduce the chemicals being used by up to 90% in some cases. Precision ag and precision irrigation is a $43 billion market by 2050, and precision irrigation is an additional 35 billion. So the number that we're starting to see out there for what the federal government is spending on broadband is an annual spend for what is going to be for agriculture going forward. Embracing automated ag. Tarana is the perfect platform to deliver high-speed broadband to aggregation points where fiber is not deployed. We are currently working on some projects where we are, quote unquote, the middle mile delivery method, getting high-speed, fiber-like speed to areas where there is no fiber. And we're going 15, 20 kilometers to do that. And we're doing it off of a central tower so we can control, again, automated autonomous vehicles that are being used in these fields, or automated monitoring or water sampling, moisture content, various sensors that are being deployed out there. One of the things that we're seeing is there's a lot of different manufacturers creating tools and platforms for smart ag, and they all need bandwidth, and they need dedicated bandwidth, and they don't all work very well together. So with Tarana's ability to offer VLANs, we can support all these various platforms and aggregation tools. But still, if you wanted to deliver high-speed broadband to these rural areas, you can use the same infrastructure to do that. Also, you need to be able to monitor your networks and understand what your networks are doing. With Tarana's cloud suite monitoring system, you're able to monitor these networks remotely and understand and react if you start to see alarms on there, what is going on with the network. So again, what are the driving factors? Money being a key driving factor out there. Water is getting more expensive for farm communities to irrigate the crops. If we can spend less money on fertilizer and be a good steward of the land to make sure we're not just dumping chemicals onto the land, that is an area as well. But there's also regulatory pressure out there. We've all heard of the droughts that go on in Central California, and the fact that farmers are begging for water. In Kansas, Western Kansas, there's a huge aquifer that people are using to irrigate land for years and years. It is now starting to be regulated and charged for some of the use on some of these waters. And there is concern that they will run out of water in the aquifer as well. So again, regulatory pressure and monitoring and being able to support saying I'm using X number of gallons of water to irrigate my land, have the proof with the network, and you do that with the sensors that are out there. So what I've done is I put together 3 use cases that we are working with integrators to develop and deploy to get the desired outcomes. So There's a large customer in California. He has well over 3,000 acres of trees that he grows, and harvesting the crops was a very costly, time-consuming, and manual process. The cellular networks could not handle the bandwidth cost effectively to automate the harvesting of the crops. So a wireless broadband network was deployed in the field, so automated harvesting equipment could be used to start to harvest. That solved the human resources issues where they didn't have enough uh, people to harvest the crops, so the crops didn't go bad on the trees. It increased the amount of area that they were able to harvest from, and in less time to do it. And they were able to do it economically. So one of the largest expenses when you are working on a farmstead is electricity. Um, whether it is automation on um, pivot irrigation, blowers, storage units, and all of that. We were able to deploy broadband to a farmstead and help optimize the grain storage on there by turning on and off the blowers on off-peak electrical hours, saving up to 50% on their electrical cost on there, and enabling real-time alerting when uh, the conditions inside the storage containers were outside of the parameters that they set, whether it's too full, too wet, um, or some other condition that is out there. And we were able to monitor and control everything remotely. And what that allowed them to do also, again, is repurpose the human resources to other jobs on uh, the farmstead. And again, automation within the tractors and farm implement communities is really starting to take hold. There are some farms where the tractor is actually controlling the wagons and the harvest storage vehicles where they store the grain they're harvesting out of from the tractor itself. Um, also, planting. They now have the ability to plant with greater precision. If you can get one more row in a field, that may not sound like much, but that field may be a mile long. So you're able to get much more production out of the land that you're using. And again, I'm coming back to the fertigation and the chemicals. If we can reduce that cost and the amount that we're using, it increases the profitability for the farmer. There's a statistic that I saw about a year ago that for every acre of farmland that has broadband accessibility to it, it increases the property value for that land. You don't have to necessarily have it deployed, but it has to be accessible to them, like $30 an acre. And again, when you're starting to talk in thousands of acres, that is a real amount of money that they're starting to do out there. If you're interested or have questions, we'd love to work with you on projects. This is the way to get a hold of your Winncom sales team. Give them a call, shoot them an email. They would love to work with you and engage us on these projects. Again, my name is Tim Yeager. I handle the account management on projects and project management on it, where we have a technical engineer. Charles Bird will help the Winncom engineering team develop up the right type of solutions. Some of Charles's background is he was one of the lead wireless engineers and communication engineers for Case New Holland. So he has deployed many, many agricultural networks on that. Questions? Does anybody have any questions coming on from the presentation? I did see two that have popped up that I'm going to address, and it'll give you a chance. If you have a question, please type it in to either the question or the chat, and we will address that. The first question that I saw is, are there federal funds available for smart aggregation? And the answer is yes. We've worked with a large Midwestern university to attain some funds so they could do some research on growing crops and harvesting crops underneath solar farms. And what that does is that starts to reclaim some of the land that we're giving up for using in other areas on there. There are federal funds that are available for tribal sustainable farming. There are some for automation that are out there, and some for autonomous vehicles. So there's many different types of funding and grants out there within the agricultural space. Can you explain a design of a typical deployment? So a lot of these deployments are very unique depending upon the type of applications that are being deployed. So I'll give you a couple different types of deployment topography. On automated tractors or autonomous vehicles, we are being deployed in a middle mile type of environment where we are providing the bandwidth to the field. And because we're fixed wireless, they are then deploying out a mobility solution out there that would talk to the farm equipment that they are using out there. We are also being deployed as last mile solutions for pivot irrigation, when they're using cameras and sensors out there. They are deploying what I call an IO block, where you can then control and monitor a bunch of different sensors fed into our radio via an Ethernet cable. And you just put a remote node out there on that side. So those are two questions that I did see come in during the presentation. I don't see any other questions in right now in the question area or anything in the chat. Dawn, do you see anything from your side?
No, I think you have them all covered.
All right. I will be sending this presentation off to Dawn so she can share it with anybody who would like to see the presentation. Again, please don't hesitate to reach out to your Winncom sales team, and they can engage Charles and myself for project review. Thank you very much.